Hello everybody, welcome to Sane Game Studios. I'm Sane, I'm an amateur game developer. Today I'm going to be doing a quick tutorial on how to do movement for a top-down game, like a Zelda clone kind of idea, like Link to the Past. I'm going to be showing you guys how to calculate the movement based on the direction, and then I'm going to be showing you guys how to animate it, and then also how to strafe once it's animated. So I have a project here that already has this going. I call it Project Lazarus because I've attempted to build this game before and it got overwhelming, and then I dialed back and made some different projects that I knew I could make, which is something that I talked about in my very first video about how I got started in game dev and what I wish I knew, is to make the projects that you are capable of making, not the project that you want to make. Okay, but anyways, as you can see, I can move around. And if I move around in any direction, it swaps that direction. But then I can also hold the strafe button and I can maintain my animation for moving in whichever direction that I am in whenever I activate the strafe function. Well, the strafe, yeah. Whenever I activate strafe, I will maintain that directional movement. But with that out of the way, now that I've shown you guys what it is we're going to do, I can hop into a blank project. So this blank project is absolutely blank. I don't need to go through like showing you what I have so far. All I have is a room. As you can see in my asset browser, everything is empty. So if I go into my room, I just have this one room. Its width is set to 480, its height to 270. And if I go down to my viewports, my camera is set to 480 by 270, just so it fills the whole room. And then my viewport is set to 960 by 540, just so I can blow it up a little bit and we can see it a little bit more clearly. With that, like I said, I have absolutely nothing, so we can just jump head first into getting this done. The first thing I'm actually going to do is I'm going to create a sprite just to represent the player. I'm going to make this sprite be 32 by 32. And I'm not going to rename the sprite because it's just a placeholder. It's not actually going to be the sprite that I use, so I don't want to have any naming conventions conflict with each other. I'll be deleting this sprite as soon as we are done building our movement system. I'm going to make it green just because green is generally a pretty friendly color. And that is all I'm going to do for creating a sprite for now. And then now I'm going to create an object, and I'm going to call this object OPlayer. I'm going to assign it the sprite that I just created, and then I'm going to go into its create event. Here, I'll increase the font a little bit so you can see what it is that I am doing. So the first thing I'm going to do is I'm going to just declare some variables, which is all that I'm going to do in this create event at all. Sometimes there's other things you want to do in create events, but for the sake of what we're doing, we are just going to be declaring our variables. So I'm going to declare my input variables. I'm going to go key up equals false, key down equals false, key right equals false, and key left equals false. And then I'm going to declare some movement variables. I'm going to declare horizontal speed, so HSP, to equal 0. Vertical speed, so VSP, to equal 0. And then input direction to also equal 0. And that's because we're not going to be moving on the x-axis and the y-axis separately. We're going to be calculating an angle of movement, which we will be storing in input direction, and we will be combining these in a sense and moving along both of them at the same time. We will still be updating our x and y positions separately, but we'll be using the same calculation to update them. And other than that, I just need my walk speed. And I'm going to set that to 3. I don't really know because I forgot to check on my other project what I have my walk speed set to. But if 3 is a little bit too fast for my animation, I will just lower that number. If it's too slow for my animation, I will make that number bigger. I think I have it set to 2 in my other one, but like I said, I'm not sure. And for the sake of this, it's not going to matter a whole lot. I'm just kind of showing you guys how to do this. Once you guys know how to do this, you can tweak it to your own needs as much as you need to. So I'm going to the step event now. And the first thing I'm going to do is I'm going to get player input. I'm going to go key up equals, key down equals, key left equals, and key right equals. Keyboard check, VK. I'm going to go up, down, left, right. Okay, so if I just blew your mind by typing all of that at the same time, how to do that is actually rather simple. I'm not sure how to do it on Mac. If you're doing it on Mac, I run Windows. So all I do is I select a spot, I hold down Alt, and I drag it down. And then you can edit as many lines as you want at the same time. Super useful for speeding up things that you are repeating, like I just did right there. So now we are getting the player input. Now we know whether or not the player is going to be pressing the up, down, left, or right arrow keys on their keyboard. Now we need to do something with them. So what I'm going to do now is I'm going to calculate direction of movement. And I'm going to go input direction equals point direction 0, 0, key right minus key left, and key down minus key up. So if you're confused as to what this is doing, it's actually rather basic. What I am doing is I am taking a point and coordinates at 0, 0, which if I were to go to my room editor, it's going to be the very top corner. So then I'm then comparing it to new coordinates that I am assigning with my inputs. So if I go to my room editor, I'll zoom in just to show you guys. So right here is 0, 0. If I was holding down the right key, I would get 1, 0. So I'd be getting a new point 1 pixel to the right. But if I was not holding down the right key and instead I was holding down the left key, I would get -1, 0. And then if I was holding down just the up key, I would get 0, -1. And then if I was holding just the down key, I would get 0 and 1. But then if I were holding the right and up key, I would get 1 and -1. And then what I'm doing here is I'm comparing that. So you have the single coordinate, and if I'm moving 1 pixel to the right, that is a directional movement of 0 degrees because everything is done from the right. So then if I were to be moving up 1, so 0, -1, and I were to compare 0, 0 to 0, -1, that would return a point direction of 90 degrees. And then -1 and 0 would be 180 degrees, and then 1 and 1 would be 270 degrees, and then this also works for the diagonals at 45 degrees, at 135 degrees, and then at 225 degrees, I believe, and then again at 315 degrees. And then that's what this does. This takes all these coordinates, compares them, and returns a value of degrees that we are storing in input direction, which is how instead of moving in the x-axis and the y-axis, we'll be able to move in a direction instead. So now we're going to calculate whether or not we should be moving. So whether or not the player is holding down keys that should be causing movement. So with this, I'm going to create a local variable, and I'm going to say move, var move, and I'm going to have it equal key right minus key left does not equal 0. So I'm going to wrap this whole thing in a lot of brackets here. Or, those two lines mean or. You can also just write the word or. I usually prefer to do that, but like I said, you can just do or. Key down minus key up does not equal 0. So what this is going to do is it is going to make sure that if this doesn't equal 0, or if this doesn't equal 0, this is going to return a 0 or a 1. See, it says it's a bool, which means Boolean. So it's either true or false, false being 0, true being 1, and then we're going to take that to multiply it with our walk speed to actually move. So what it's going to do is that one of these has to return true. So if you're holding any key, then it will move. But if you're holding the up key and the down key, that will return a 0, in which case this would return a 0. Because if you're holding down two opposing keys and nothing else, if you're holding left and right, we can't move because it wants us to move equally in two different directions, so they cancel each other out. And this is how we get it to cancel each other out. And now we are going to calculate movement. And this is where our HSP and VSP comes in. We're going to go HSP equals length dir x. This is going to take two arguments, length and direction. The length is going to be walk speed multiplied by move. And then the direction is going to be input direction. And then we can actually copy that, paste it, and the only thing we need to change is Y and VSP. So what this is going to do is it takes two arguments. It takes a length. The length is going to be our walk speed, and then if we are moving, move by that walk speed. Otherwise, this is going to return a 0. Or if we are supposed to be moving, walk speed is 3, so 3 times 1, it's going to return a 1. So it will return a 3. So 3 times 1 will return a 3. So then we are moving in we are moving 3 pixels in this direction, And this is used to calculate how far along the x-axis we would be moving if we were doing this in the x. Yeah. And then we're doing the same thing in the y-axis, where we are giving it an amount to move, a direction to move, and then it takes it, creates like a triangle, and then calculates the hypotenuse, and then feeds it into like, you know, the VSP kind of idea. And then we're going to commit to movement. I'm going to go x plus equals HSP and y plus equals VSP. And that is all we need to do for just moving. It's honestly not as complicated as it looks. The only real difference between this and just doing the x-axis and the y-axis completely separately is the fact that we are creating a direction to move so that we can cover our basis for directional movement. So for diagonal movement. So now what I'm going to do is I'm going to pop my player into the room. And now, as you can see, I can move in any direction. But we don't want to be moving as just a green square. As friendly as the green square is, we actually want some animation. We want to be moving around as a person or like an animal or, you know, whatever it is that you want to move as. It could be a ship, it could be a freaking anything. But it's not a green square. Unless you want to play a game as a green square, honestly, I think games are more interesting if they're not green squares. So let's show you guys how to make it so that it is not just a green square. So, as I said, this sprite is just a placeholder. So I'm actually going to set its sprite to no sprite because we actually don't need, we can assign the sprite completely through code. And I'm actually going to delete this sprite. So now what we're going to do is we're going to go to sprites. We're going to create a new sprite. Excuse me. And the way that I do this is I'm going to create 4 separate sprites, 4 separate animations, one for each direction. There are ways to do this where you would put all of the directions into one animation. So instead of 4 separate sprites, you would have one sprite and it would just move in all 4 directions. And you would calculate which frames to use for each direction. I personally find that to be needlessly complicated. I know how to do it, and like it's not exactly rocket science, but I prefer not to. So when I do it, I do 4 separate sprites. So these are going to be the sprites that we're actually going to be using. So this time, I'm actually going to introduce some proper naming conventions. So I'm going to call this one S player walk right. I'm going to import an image. And this is an asset pack that I actually purchased. It is available on itch.io. It's done by Elv Games, and he actually makes some really great asset packs. I am not a pixel artist. I'm not great. I can edit these to make them into what I want, and I normally do have to edit them, but I'm not great at creating them in the first place, so I just get asset packs. I'm going to rename this, and if you guys watched either my platformer movement video or part 2 of it where I get deeper in animations, you're going to understand what it is that I'm doing here. If you haven't watched those, I'm going to explain it real quick. So GameMaker will actually split the sprites up into their separate frames if you tell it how to in the name of the image file that you import. So here I have character 1 walk right, and to the end I'm just going to go underscore strip 4, and that's going to tell GameMaker when I import this that there are 4 frames to this sprite. So it's going to take the overall width of the image, it's going to divide it by 4, and it's going to split each segment into 4 separate frames. So now that I've done that, I can go open, and as you can see, it's already split. But also, as you can see, the guy looks like he's full on sprinting. So I'm going to change this to a 7. And that looks like a much more manageable walk speed. I'm going to do the exact same thing 3 more times. Okay, so now I have all 4 of my directional walking sprites imported. I have them all set to 7 frames per second so that they all animate at a relatively, well, not relatively, an exactly equal rate, so it always looks like he's going to be walking at that set speed. Look at him go. Look at that little boss. What a cute little bugger. Alright, so now that we have these, we need to implement them. But implement, I mean we need to assign them to our player object. So I'm going to go to OPlayer events. I'm going to go back into my step event. I'm going to go below and I'm just going to say animate the player. So the first thing actually I'm going to do is I'm going to go to my create event and I'm going to create a new variable and I'm going to call it dire facing, and I'm going to have it equal 0. And then I'm going to, another comment, set dire facing. I'm going to create a switch statement, and I'm going to use input direction. I don't know if you guys have used switch statements before. It is essentially a multi-layered if statement. So instead of being like, if input direction equals 0, do this. If input direction equals 90, do this. If input direction equals 180, do this. Instead, I can create a switch statement and I can make cases for each one of those. So I'll show you guys how to do it. It's rather simple. I'm going to go case 0, which is essentially saying if input direction equals 0, I'm going to say dire facing equals 0, and then break. I put the break here because if this is true, do this, but then when I put the next line, I want it to not do that. So I have to tell it to break so that it exits out of the switch statement and then either keeps running code or restarts for the next frame. Case 90 dire facing equals 1, break. Case 180 dire facing equals 2, break. Case 270 dire facing equals 3, break. And the reason I do this, and honestly there isn't a whole lot of reason why I have to. I could, instead of going dire facing, I could just say sprite index equals and then add in my sprites. Personally, I don't really like to do that. I'd much rather have a dire facing variable that I can reference, and then also I'm going to be using dire facing to do the strafing mechanic at the end, and I don't want input direction to be affecting my sprites while I'm strafing. Because if I'm strafing, I want my sprites to stay exactly what they are, whereas I always do want to be updating my dire facing so that when I release the strafe, it will then automatically go to whatever it is that I want it. I'll show you. So now that I've done that, I'm actually going to create another switch statement, this time for dire facing. I'm going to go case 0, sprite index equals S player walk right, because 0 degrees is to the right, and if input direction is 0 degrees, dire facing is 0 degrees. So if dire facing is zero, I know that I want to be moving to the right. Break. Case 2. Sprite index equals S player walk up. Again, 90 degrees is up. Oh, sorry. Case 1. 90 degrees is up, and dire facing is set to 1 when we're at 90 degrees. So I know that I want to set my sprite to walking up. Break. Case 2. Sprite index equals S player walk left. Break. I'm going to put a comment here. Set sprite. Case 3. Sprite index equals S player walk down. Break. And then now I want to set the animation speed, because if we are not moving, we don't want to look like we are moving. So I'm going to say image speed equals move. Yeah, okay, cool. I turned yellow. That worried me for a second. So what it's going to do is it's going to set the image speed to equal 1 if we are moving and 0 if we are not moving. But also, if we are moving and we stop moving, image speed is going to be set to 0, and then if we are mid-step, we will stop mid-step. And actually, I can show you that right now. See? Not only does it stop mid-step, but also it always defaults to moving to the right, well, facing to the right. So what we're going to do is we are actually going to wrap this switch statement in an if statement and then say if move equals true. And now if we run it, but again, it stops mid, and then also it doesn't actually display the animation until we move. So to fix that, we're going to have to do this, which is something I said we wouldn't have to do, but it is something we're going to have to do. And I'm actually going to set it to walk right. So now, if we run it, like I said, see, we can pause mid-step and the animation actually stops. So to fix that, we will go reset idle animation. And I'm going to say if image speed equals 0, then image index will also equal 0. And what that'll do is that if you are not moving, it will reset whatever animation you were on to the very first frame. This is frame 0, frame 1, frame 2, and frame 3. Now if we run that, we now animate beautifully. Like perfectly. We stand in place and we don't stop looking like we just took a step. And we just stand there. But I also told you guys that I would show you how to introduce a strafing mechanic. So to do that, I'm going to go back to my declare input variables, and I'm going to create a new one called strafe, and I'm going to have it equal false. And then in the step event, I will go back up to get player input, and I will go strafe equals keyboard check VK shift. I'm going to use shift. You can use whatever key you want. I personally am going to use shift. And then what I'm going to do is I am only going to update dire facing if we are not strafing. You could also do this by going if move equals true and not strafing. But I use my dire facing for more than just this, so I want to make sure that I use my dire facing because I want the game to know that this is the direction I am facing, even when I am strafing. So this exclamation point is the same thing as going if strafing equals false. It's just another way to, shorthand way to write it. But it is the exact same thing. And now if I run it, oh, strafe. It's not strafing, it's strafe. So I can move around, everything's fine, and then if I hold strafe, it no longer updates the direction of my sprite. Which, like I said, has a lot of applications. You can use your imagination for that. I had to figure out how to do it myself because nobody really covers strafing in top-down games. It's not really needed for games where you use your mouse to shoot or something, but it would be needed for games where you don't use your mouse to shoot, but you still want to be able to strafe. But yeah, that is how you do that. I believe that's all that I got for you guys today. So I'm going to thank you very much for watching. I know that it was a little bit messy of a tutorial. Like I said, I'm an amateur game developer. I'll call myself a real game developer once I have actually released a commercial game, which I am currently working on. I'm actually working on 2, just so I can take a break from one for a little bit. My one game's actually in a state of getting tested right now, before I continue building it, so I can nip some bugs in the bud before they become major problems that are big to fix. So while I'm getting my one game tested, I am beginning my next project. But yeah, once I have a commercial game released, I will just call myself a game developer. And if that game makes me enough money to do this full time, I will call myself a professional game developer. Because somebody that makes a living building games is, well, somebody who makes a living doing something is what makes them a professional at doing it. So, but yeah, as it sits right now, I'm an amateur game developer, and I just do my best. And I hope this tutorial was useful for you. I hope that my explanations were enough. If you have any questions, you can feel free to ask them down in the comments. But yeah, that's all that I have for you guys today. I hope this tutorial was helpful. If you have any questions, feel free to comment them down below. If you have just any comments at all, feel free to shoot them down below. Like I said, I'm sorry that this tutorial was a little bit on the rough side. I usually do these things at like 6 in the morning on a Sunday, so I've been awake for about as long as it took me to record this, which so far is about 42 minutes, but I'm going to be editing it down, so I'm thinking it's probably going to be about a half hour, 35-minute tutorial. If you guys don't need the whole thing, like always, I put my chapters down below. I should have said that at the beginning, not at the end. But yeah, thank you so much for watching. Please like and subscribe. Comment if you have any questions. If you do have any questions and you comment them, I will absolutely do my best to answer any and all questions that you have. If you're interested in having just one single animation, one single sprite that handles the direction and handles the animation for all directions, Sarah Spalding has a really good tutorial on that in her action adventure RPG series. I believe it's episode 2. But yeah, with that, again, thank you very much for watching. I hope you guys are having a good one. Please like and subscribe, and peace out.